Hey, what's up everyone? Your buddy Matt here. Welcome back to my channel. Booster packs, battery packs, jumper packs, it's all the same thing. If you work around internal combustion engines, odds are you own one and you use one fairly often. What's the difference between this one and that one? This one is broken. And that's what this video is going to be about today. So if you've been on my channel before, you may have seen my Toro Groundmaster revival video. In that video, I used this booster pack to do something horrible, and that horrible something was this. Go better if we have the spark plug on. You guessed it, folks. I ended up using this on-off switch, basically intended just to power up the booster pack in order to start the starter. You do that by connecting it up with the switch to off, right up to the starter, not to the battery, right up to the starter. And then when you put this guy to on, it ends up powering up the starter. You might think that's fine, but in reality, it's not. Enter this guy over here that's done it several times in its life, and this switch has ended up failing miserably. Today we're going to fix that. We're going to fix the switch, but we're also going to modify the pack in a pretty cool way. Stick around. Let me show you what we're going to do. All right, so here we are, we're inside it, kind of split it open. It's still held on by these wires. I can't split it apart just yet, but we'll get there. This disconnect switch is hooked up right to the battery. I removed the nut that was on there. Actually, we're gonna move this handle, remove this nut, and kind of pull it out. As you can see, this switch totally melted. Now you might be asking yourself, why did this switch melt? When you use a booster pack properly, you end up hooking it up to a battery, and then you turn it on. At that point, the battery will begin siphoning current from the booster pack, but it does so gradually. If you hook this guy directly up to a starter and use this to basically send current directly to the starter, that starter could be pulling hundreds of amps through this switch. That's definitely not rated for that. I mean, you can see it's made out of plastic, and just by looking at the size of these terminals, you know that it's not rated for several hundred amps. So when you think about what a starter actually uses in something like a car or a piece of equipment, it uses a solenoid, just like these over here. They can handle several hundred amps of current flowing through them. And the way they do that is there's a coil in here that you'll send a small amount of current, energize the coil, and then a large contactor will come and bridge the gap between these two terminals, hence sending hundreds of amps to your starter. Back to this guy over here, definitely not rated for that just by looking at its construction. So I actually went online to try to find a replacement part for this booster pack, and it didn't have to be the exact part, but I wanted like a mechanical switch that I could incorporate into this pack to get it running again. That was the initial plan. I figured I might be spending 15 or 20 bucks to do so. And when I went online to find it, it does exist. You can find these kind of mechanical switches. I wasn't able to find one that was exactly like this one that I could just fit right in. They tended to be quite a bit larger. And when you looked at the amount of amperage that they could handle, it was always fairly low. Like it was under 80 amps in pretty much all the cases. So my next thought was, why don't I incorporate a solenoid right into this thing? There are some pros and cons to doing that, but this would basically allow this booster pack to function in two ways. One, as it was intended to boost batteries, or two, to be able to hook it right up to starters and start things with it without damaging the circuitry. So I went into my stock and I found these two solenoids that I had. This one's brand new, and this one is a good used, or what I like to call an emergency backup only, because it's used, but I figured I could incorporate this into the booster pack, but that's when I hit my first hurdle. If you take a quick look inside this thing, it's already pretty compact. Basically, the only place where I could incorporate something was down here next to the compressor. This booster pack has a compressor, by the way, which, a lot of them don't, but this one has. And when I asked the owner, because by the way, this doesn't belong to me. I'm not the one that messed it up, folks. I asked the owner if he wanted to keep the compressor, and he says, yes, I do. So this guy was pretty much out the window because it was too big, but I figured this one would probably fit. And when I tried sort of looking at how it would get in there, it definitely interfered over here. So back to the internet I went, and this is what I came up with. Behold, a giant relay. Usually when you think of relays, you think of something like this, fits in the palm of your hand. They're good for probably 30 or 40 amps. They make bigger ones that can go up to 80 amps. But that still wasn't enough. But that's what gave me the idea to go look for high amperage relays. And that's when I found this big guy. In reality, a solenoid is a relay. Like, these are basically the exact same thing, except, these are the ones that you would most probably see in equipment or vehicles. This would be used in maybe a cabinet or controls. I kind of doubt, this is supposedly a 200 amp. I really doubt that, but I know that it fits, or it should fit in here, and that's what we're going to go with. I mean, we'll give it a try. This thing was, I think, $17 Canadian. And if it doesn't last, I mean, we'll figure something else out. But no, I kind of want to give this thing a try. I think it would be pretty well suited for this application. So before worrying about fitting that giant relay in here, let's just understand what's going on with this switch. I mean, we're not going to cover how all this works because, quite frankly, no one cares. But this guy over here, this is the output side, and that's the side that ended up toasting. On the input side, this guy was hardwired or wired up directly to the battery with this little tab. That's going to have to go. We're going to have to get a wire going from here to our relay, and then the other side of the relay, basically this is going to become, like, the relay is going to go here like this. Like, this is going to be the relay. And then to power this relay, we're going to have a switch, but it doesn't have to be something as heavy duty as this. It could be any type of switch. This guy over here had a power wire hooked right up to here, so sending positive 12 volts to the circuitry. I guess, when you want to turn on just the air compressor or what, without sending power to the jumper wire. This guy over here, however, I don't know what that does. Most probably this guy was activated when it would be on. And then it had this wire that's hooked up to the output. So we're going to keep that as is when we incorporate the relay into this guy over here. All right, let's give ourselves a little bit more room. We'll now that you've seen how this guy is hooked up and how it sort of failed, we'll take this wire off, disassemble this switch over here. We'll be replacing this terminal because it's severely damaged. This guy here should come off fairly easily. There we go. And then this wire, we'll end up putting a terminal on there, and we'll figure out what we do with this. Next thing we want to do with surgical precision is chop out these ribs over here with an X-Acto knife. All right, so that went quite a bit easier than I was expecting. Good for me. Let's fit this relay in. What we're going to do, I was looking at different ways of orienting it, but I think the best way is going to be like this. That way there we got ample clearance for the mechanical movement of the little piston that's using that compressor. And we have our connections are going to be kind of facing us. So when you split this guy open, it's going to be easy to work on. Hopefully I never have to do that. But I mean, if ever we do, we'll have easy access to it. So we're just going to drill a little hole and use the tab on the back of this guy to secure it in. So my initial idea was to use kind of like a big piece of heavy-duty wire, and then just use these crimp-on connectors, or I guess solder on as well. But I had it in my mind that I was going to crimp them, and I didn't have a crimping tool. And I know I could just use like a vise or some vice grips or whatever, but I didn't like the setup. So I ended up going to Canadian Tire, and I was actually going to buy I was actually going to buy different connectors, and they were $6 for 2 connectors. And then I noticed this. This was $8, and you got the wire already included. So I took an 18-inch wire. These are tinned connectors on top of it, so copper with, like, I guess a sort of like a solder right on top. So corrosion resistance, and that's it. And it was like $2 more. And then look, they're already all crimped, professionally made. You know, $8, whatever, good enough. So now we're going to go from, I guess, the output. Either one doesn't really matter, but we're going to go from one to the battery. You know what? We're going to be using this bottom one because we have ample wire length, and the top one is going to have to be the connector. You know, the actual terminal that normally would have been higher up is going to have to get creeped down in there and hooked up to there. So we'll gain 1.5 inches by doing it that way. And we'll see how we weasel this guy. Yeah, we're going to kind of go, we don't want it interfering with our compressor, but yeah, I guess something like that should be okay. And next thing's next, we're going to fix up this guy over here. We're just going to give it a little bit of a snip like this. And we'll get a brand new terminal on there. Perfect. Same thing for this guy right here. All right, so what do we have? We had this guy over here that was hooked up to the, I guess, positive 12 volts coming from the battery, which was this one over here. So we're going to have to take that nut off and put this guy back on. This one was hooked up to the output side. I think that was on the melted end. And then this guy was kind of the unknown one. We're just going to take a guess, and we're going to put it on the output side as well. So this, and we're going to pull this guy, whoops, we're going to pull this guy in, and we'll put this guy on as well. So this guy doesn't go on first. So we'll fasten on our little nut. Okay, so when I removed this guy over here, I ended up putting washers and stuff, and I had enough material on that connector. What I ended up doing was I ended up drilling a new hole and topping off, just cutting off the top. So now it fits in there nice and snug. I ended up putting on that 12-volt power wire. And this guy too, I made a new hole that's going to go. We're going to remove this plate, and we're going to put it right on the bolt. So now this guy's going to get attached. This guy's going to get attached to there. And that's going to complete, I guess, the power end of the switch. Next up is going to be the control end, what's basically going to turn on and off that solenoid. So from a control standpoint, in order to activate the solenoid, we're going to be using this switch. I actually went more into detail on how these switches are kind of, how they work in a previous video I made, the one on getting the Toro Diesel Groundmaster started. But real quick, these are more seen in, I guess, industrial automation applications. Really, really cheap. I mean, it's a couple dollars. They kind of come in parts. This is a selector that has a a fixed position, a second fixed position, and then a momentary spring return. So they call it a 3-position, but one of them is a spring return, and you're going to see why in just a second. And then you can add on the normally closed or normally opened. In our case, it's normally open that we're going to be using contactors over here, mechanical contactors. There's a small lever in here that ends up activating them. So if you pass current in them, let's say if we're normally opened, in this neutral state, current will not pass. And then when you activate it, current will pass. So in our case, middle does absolutely nothing. When we turn it to the left, we're going to be running constant current through this switch over here. And when we turn it to the right, on the spring return movement, we're going to be sending current through this switch over here. what we're going to do is install this where the previous on-off switch was, and we are super, super lucky. I removed the screws off this to take this guy apart, and this is what it looks like. This is actually a cover. This is, I guess, a switch that would have been modified for this application. We don't need that anymore. What we need is this, and we were really, really lucky. The diameter over here is perfect for this switch. So this guy is going to get disassembled and fished through and connected into here. And this is the perfect fit to fit right back in, you know, stock style, right in over here. So mounting this switch is really going to be a breeze. I mean, so far, the only thing I'm going to have to do is cut off these tabs so that the switch actually fits in. This is an interference right now with these tabs. We're just going to snap them off. Let's get this switch installed, and I'll show you how we're going to hook it up electrically. Here we have the finished product. It just looks perfect. It looks stock. So basically the off position is still going to be here. The on, permanent on, in order to, let's say, hook it up to a battery, is going to be to the left. And then if you want to hook it right up to a starter, you're going to have a spring return. Start and let go, and it shuts off. So you're not going to worry about keeping the starter on, you know, and damaging the starter. So that's my little innovation over here. And the only reason why we can do that is because now we're using a solenoid, which, by the way, I didn't like the height. I was too nervous that when we reassemble it, the height was going to be too high. So what I did was I ended up snapping off the base. There was a tab over here, and I ended up using a bolt. Snap that off. I'm going to put some hot glue, and that'll allow it to sit at least 3/4 of an inch lower. So I like that much better. But before we do that, we're going to finish wiring this guy up over here. Let me show you how I want to do that. So you guys ready for this super, super simple circuit? Here it is. Ultimately, both of these switches will end up doing the same thing. They're both just there to send 12-volt power, positive 12 volts, to the solenoid coil in order to energize it. The magic is really the switch itself, whether it's in the fixed position or the spring return position. So we're going to come up with a signal from the battery. So this guy gets hooked right up to the battery, the positive 12 volt on the battery, comes in here and energizes, or at least sends power to both switches. However, because they're both normally open, they don't let any current through. Like we said before, if we put it on the fixed position in order to hook it to a battery, the current's going to pass through and go off. It doesn't matter if the current ends up coming back across over here, because this switch doesn't allow anything to pass through it. Same thing when we go to the momentary side and we activate it, it'll be pulling in the power from here, sending it over to here and along its way, and once again it can't come back through here because this switch will always be open when this guy's in the closed position, and vice versa. This end here is going to get hooked up to one of the terminals on that relay. The other one is going to get hooked up to ground, so we're just going to go right to the negative post on the battery, unless I find a ground somewhere else, but I think I'm just going to go right onto the battery. It's going to be easier, so this is really going to be a simple circuit like that. Let's get it wired up and see if everything I'm talking about makes any sense and whether or not it works in my application. So moment of truth, I got the multimeter on DC voltage hooked up to the two power leads, the ones that you would hook up onto your battery or your starter. And we wired it all up as you have seen. So let's see if this guy works. First thing we're going to do is we're going to put it to the on position. And sure enough, we're sending 12 volts to the two leads that would go on your battery. If I test here, this looks like it's like a, I don't know, you can test and see how strong your battery is, so that doesn't automatically go on. You have to actually test your battery. Then we have the light. Light works, and air compressor works as well. Now let's check and see in the start position. So this is off, and now we go to start, and sure enough, it works as well. So that appears to be a success. Let's put it back together, and we'll talk about the pros and cons of using a solenoid in this, and we'll also try it out on some equipment. All right, so you guys probably already know how a starter pack works. You just hook the negative up to the negative, positive up to the positive of your battery, and then you let the internal battery of the pack give it a little hand. You wait a couple seconds, and you start it normally, and it should work. In our case, we modified it to hook it right up to the starter, and now we're going to give it a try. The key is on, but we're going to use the key on this guy to end up starting the tractor. Let's see if it works. So wrapping up, let's just go through real quick the pros and cons of what we did to this thing, because it's not only benefits. Obviously, the benefit that we have is we ended up fixing the booster pack, and we ended up turning it into something that it wasn't before, a combo starter pack slash regular booster pack. There is a drawback to what we did. Anytime you add complexity to an electrical circuit, you end up adding more components, and those components can fail. So we added not only a selector switch, but a solenoid. Either one of those components can fail. So, you know, there is maybe reliability issues down the line, but I'm not too concerned. And honestly, I think we made the pack a lot more robust by having a switch that can actually handle this guy's capacity. The second negative factor is if ever you were to use your pack as a portable power pack, that solenoid draws, although small, a constant amount of current. So as soon as it's on, regardless of how you use it, in order to energize the solenoid, you're using up electricity. So if you forget the pack on and you leave it there for maybe a couple hours, a couple days, you come back, it could be dead. If you end up wanting to have a maximum battery capacity, let's say if you're powering stuff, you're out camping and you want to really use it as a power pack, know that we sacrificed a little bit of capacity in order to have that solenoid. But other than that, for my purposes, it's going to be fantastic. So that pretty much wraps it up for this video. I hope you guys enjoyed it. Stay tuned for the next one. Signing out.